Alright, in the following two videos I'm going to solve logarithmic inequalities. So in this video I will solve relatively simple ones, and the next one it will be rather saying basic ones, and in the next video I'm going to do advanced logarithmic inequalities. So question number 1. Solve the following inequality: x minus 1 times logarithm x by base 2 plus 1 is greater than 0. So let me remind you, when we have product, right, and it's greater than 0, which means it's going to be, result has to be positive. That means either both these parentheses are going to be positive or both of them are going to be negative, right? And because of this logarithm x, we know that under the logarithm we cannot have negative numbers. So our domain here, it's going to be x greater than 0. Okay, so x minus 1 times logarithm x by base 2 plus 1 greater than 0. And this is mean, from here we can say that x minus 1 has to be 0, or x minus 1 has to be less than 0. So when x minus 1 is greater than 0, that means logarithm x by base 2 plus 1 also greater than 0, right? And in this case, when x minus 1 less than 0, then logarithm x by base 2 plus 1 also has to be 0. So the final result would be positive, right? And the first condition we are plugging here, x has to be greater than 0, because we cannot afford x is less than 0. Therefore, x greater than 0 I include in the set of inequalities. So it is always a good idea when you are doing solving inequalities to include a condition for domain in this inequality, so you won't forget and always be considerable of this condition. Okay, so it's going to be either or. Let me put the sign, either or. All right. So let's go over first set of inequalities, which is going to be x minus 1 greater than 0, logarithm x by base 2 plus 1 greater than 0, and x greater than 0. Okay, and from here we are going to have x greater than 1, logarithm x by base 2 greater than negative 1, and x greater than 0. All right, and from here we have x greater than 1. X is greater than 2 to power negative 1, or rather saying, so I wrote down this way, you can see 2 to power negative 1, right? Or the best way to write down, greater than 1/2. Okay, and x is greater than 0. So what do we have? X is greater than 0, greater than 1, greater than 2. So solution here is going to be what? X is greater than, let me write down here, x is greater than 1, right? Satisfying answer. Why? Let me real quick explain. This is 0, greater than 0. Then it's coming greater than 1/2, coming here. And the third one is going to be greater than 1, coming here. We're all three satisfying the area. We're satisfying all three conditions, starting from here. Greater than 1. All right. So therefore, the answer is going to be x is greater than 1. Let's go over next condition. So we have x minus 1 greater less than 0. Logarithm, it's going to be the same, this three inequalities, but with condition of less than. Logarithm x by base 2 plus 1 less than 0, and x is greater than 0. Okay, so from here we have x is less than 1, logarithm x by base 2 less than -1, and x greater than 0. Okay, what do we have from here? X is less than 1. And in the case of logarithm, we will get x is less than +1/2, right? Okay, and x is greater than 0. So let's see what is going to be final answer. So we have x is 1, less than 1, right? Then we have 1/2, less than 1/2. And then we have 0, greater than 0. So where they are overlapping? They are overlapping in this case, right? In this interval. So the answer is going to be here. X is greater than 0 and less than 1/2. Okay? So this is the way we got practically our answer. Our x can be or belong to, this way, this symbol meaning belong, all right, belong to interval from 0 to 1/2. As you can see, equal sign is not included, therefore we don't use square brackets. Or it's going to be from 1 to +infinity. Okay? Next one, we have inequality number 2. We have log by base 3 to power x plus 1 plus x greater than 2 plus log 10 by base 3. All right. Change the color so we can see better. All right. Okay. I'm going to write original problem so I can start solving. So when I need, I can scratch, underline, and the original problem, leave it alone. Okay, so from here, how we're gonna solve? It's gonna be logarithm 3 to power x plus 1 by base 3. Now look what we have here. We have x, we have 2 without logarithm. When you have logarithmic inequalities equation, it's the best way to solve, to turn all of them into logarithm format. So to apply properties of logarithm, it can be easy to solve it. So what I'm going to do with x, if I have logarithm by base, since I have here base 3 everywhere, right? In this case 3, in this case 3, obviously I want to take base 3. So to have the same base, because all operations you can do only and only if you have same base. So here should be 2, this is my x, because I have to have here this x here. I'm replacing this x with logarithm. So 3 to power x, and here I have to put 3 to power x, right? So to replace x with logarithm, I have to put plus logarithm 3 to power x by base 3 greater. Now 2, if I have logarithm, again I want to make sure it's going to be base 3. So, and the answer has to be 2 because I'm replacing 2 with a logarithm. So what number it's going to be here? 3 to power 2 is 9. So I have to have here 9. Because logarithm 9 by base 3 is equal to plus logarithm 10 by base 3. Yes? Okay. So from here, hence, what we are going to get, I'm going to use properties of logarithm, which is sum of logarithms is equal logarithm of the product. Right now, let me write down logarithm a by base c plus logarithm b by base c is equal logarithm a b by base c. Okay, so we have logarithm by base 3, and I'm writing down monomial first. Monomial meaning one term, which is going to be 3 to power x, and then times by binomial, which is 3x plus 1, binomial 2 terms, okay? And greater than logarithm by base 3, it's going to be 90, right? 9 times 10. 9 times 10, okay? All right, so next step, if I have logarithm a by base c is equal logarithm b by base c, meaning the same, the base is the same, then we can drop the logarithms and say a is equal b. And that in a case only when base is the same. And we do have same base. That's why I took 3. It's easier to work when bases are the same. So from here, I'm going to get 3 to power x plus 1 is greater 90. This is nicely how we got rid of logarithm. Okay? So from here, I'm going to multiply. It's going to be 3 to power x. Distribute plus 3 to power x, and that is greater than 90. Or 3 to power x squared plus 3 to power x minus 90 is greater than 0. Okay. What we are going to do from here, we are going to substitute 3 to power x with y. Okay? So 3 to power x is equal y. From here, I will have y squared plus y minus 90 is greater than 0. And I can FOIL it. Y plus 10 times y minus 9 is greater than 0, right? Okay, I'm bringing substitution. 3 to power x plus 10 times 3 to power x minus 9 is greater than 0. Since in this case, usually we say both of them have to be positive or both parentheses have to be negative. Negative case here is eliminating because you have 3 to power x. Even if x is negative, you still get positive fraction, but positive. So negative case for this inequality is not going to work. So we're going to have both of them positive. So it's one case, it's 3 over plus x. 3 to power x plus 10 is greater than 0. And the other case, 3 to power x minus 9 is greater than 0. Now this one, 3 to power x greater than negative 10, is not going to work because you cannot have negative the sign 3 to power x never going to be negative because, like I said, even if its x is negative, it's going to turn into fraction, the fraction, right? Well, let's say negative 2 will be 1 over 9. So it's not going to be negative under no circumstances. That's why this solution falling out. And we have left only this case, 3 to power x greater than 9, right? And I'm writing down 3 to power x greater than, I'm writing down with the same base, 3 to power 2, right? And if bases are equal, that means exponents also equal. I mean, use this condition. If it's greater, then x is also the greater than 2. And it's going to be greater than 2, so the solution is going to be the answer. It's going to be x belongs to interval from 2 to positive infinity. Let me put positive. There we go. All right. Moving to inequality number 3. We have 1 plus 2x less than logarithm 1 plus 6 times 7 to power x. And it's by base 7. All right. So let's write down solution. So 1 plus 2x less than logarithm by base 7, 1 plus 6 times 7 to power x. So from here, I'm going to get logarithm by base 7. Let's see what I'm going to put there to replace 1 plus 2x. I could do substitute 1 and then separate 2x, but I don't need that. It's easier to substitute these two together, right? It would be much easier. So this is what I'm going to do. I have here log, and I know it's going to be 7 definitely because we have here 7, right? Okay, so what log I have to have? That result is going to be 1 plus 2x. It's going to be 7 to power 1 plus 2x, right? And that's going to make it, right? So logarithm by base 7, 1 plus 2x. Oh, no. What am I doing? To power 7 to power 1 plus 2x. Now this will make it. Okay? And then this is less than logarithm by base 7, 1 plus 6 times 7 to power x. Okay. And from here, what do we have? 7 to power 1 plus 2x is less than 1 plus 6 times 7 to power x, right? Because we have same log with same base, right? That means we can drop. And we will get inequality with rational exponent. All right, now I can solve this rational exponent. 7 to power 1 times 7 to power 2x. Remember, properties of exponent. So when you do multiplication, base is the same. Let me write down. A to power x times a to power y is equal a to power x plus y. Now we have opposite. Plus y, I'm breaking down into x and y. So 7 to power 1 plus 7 to power 2x minus, I'm bringing here minus 1 and minus 6 times, this is times, guys, 7 to power x, and this is less than 0. Next, I'm doing, to solve this inequality, I'm doing substitution. 7 to power x is equal y. And as a result, I am getting 7 y squared minus 6 y minus 1. It's equal 0. Okay, I put there 0. So this is going to be, let me see which way I'm going to solve it. All right, let me solve the following way. Ax squared plus bx plus c is equal 0. x1, 2 is equal negative b plus minus b squared minus 4ac. I call this method as a universal method. You can apply this to any quadratic equation. Okay, so what is my a, b, and c? So my a is 7, b is negative 6, and c is negative 1. Okay, so from here I will have y1, 2 is equal 6 plus minus 36 plus 28 over 14. So you can do step by step there. I'll just multiply it in my mind. So this is equal 6 plus minus 8 over 14. And from here, y1 is equal negative 2 over 14. And y2 is equal 1. Okay, so from here we have 7y squared minus 6y minus 1. It's going to be equal 7 times y, here is minus, so it has to be plus. Well, 2 over 14 I didn't notice, so we can put 1 over 7, right? 1 over 7 and y minus 1. Okay, so from here we are getting 7 times, I'm bringing back 7 to power 2x plus 1. So it's going to be 7 times 7 to power 2x. Let me see, this one. Okay, 7 times 7 to power 2x minus 1 minus 6 times 7 to power x. So it's going to be to power 2x minus 6 times 7 to power x minus 1 is less than 0. Hence, 7 times 7 to power x plus 1 over 7, because we substituted, remember? We substituted, where is it? Oh, right here. We substituted 7 to power x equal y. So bringing back, instead of this y, I put 7 to power x, right? Plus 1 over 7, and then 7 to power x minus 1 less than 0. Okay, so 7 to power x, so it can be greater than 0, less than 0, because it's less than, so it's going to be two different signs, right? If this is, let me see, if this is plus, this is going to be minus. If this is minus, this is going to be plus to get negative. But the thing is, because here we have plus, so this 1/7 will go on the other side with negative. Let's say 7 to power x, it's going to be plus, let's say plus 1 over 7 less than 0. Okay? We are getting 7 to power x less than negative 1/7, which cannot happen. Remember, this 7 to power x is never gonna turn into negative sign. Even if it's we have 7 to power x plus 1 over 7 greater than 0, it's still same thing. So therefore, this is we are dropping. This is not gonna work, and we have for solution only this case, 7 to power x minus 1. So since only this one left, then there is we don't have other choices. It's just less than 0, correct? There is nothing to connect with. So 7 to power x minus 1 is less than 0. From here, 7 to power x is less than 1. And to solve this inequality, I'm going to represent 1 as a 7 to power 0. So just like in the case of logarithm, if base is the same, then the exponent also going to be the same. So since we have x and 0 and less sign between them, then it's going to be solution x is less than 0. And from here, the answer is going to be x belongs to interval negative infinity and 0. Okay, I guess I will stop here, and this way I will make 3 videos instead of 2, because I don't want to make video too long so you will get tired. So all right, I see you in next 2 following videos that will elevate as I solve these logarithmic problems. Okie dokie, thanks for watching. See you again.